search through a really big pile of data. Okay. One thing to say about asynchronous programming is that, if possible, it's always nice to let your host environment do it for you. So a lot of us who write code, especially web applications, and our apps are going to be hosted in IIS or SharePoint, we don't worry about writing asynchronous code because we figure the environment that's hosting us is going to take care of that. It's going to take care of having enough threads, of utilizing the CPU power and the network connectivity of the server, and it's going to isolate our code. Each time we respond to some kind of request, we're going to be doing it in a thread we didn't have to create. You don't have to worry about what happens to it when our code finishes. Okay. Now, I think that it's pretty clear that even though we've been able to get by, and a lot of us without doing a lot of asynchronous programming, and I'm in that category, you've been able to get by without doing a lot of asynchronous programming either because you just don't care, your program is responsive enough and runs fast enough without you needing to do anything asynchronous, or because you have a server sitting underneath you, a hosting environment sitting underneath you that's taking care of it for you. Nonetheless, it's becoming more important, I think, all the time for programmers to get into the swing of writing their own asynchronous code, and this is why. The trends we see are that on the client side, people use thinner and thinner clients, smartphones, tablets, mobile devices, and very thin, what passes for a laptop these days. You have to run in this environment where there isn't a lot of data sitting around locally, there isn't necessarily all the logic you need sitting around locally. You have to make external calls to get it. And these calls can be slow, you need to be able to, and yet you need your user interface to be responsive. This smartphone here has actually a very dumb interface. And I have one window open, I can't switch to something else easily if whatever I'm looking at locks up and because it's calling a web service that's gone to lunch. So in many of the programming frameworks, and Silverlight was, how many have you done Silverlight programming? A few minutes. In Silverlight, many kinds of APIs that were either synchronous or asynchronous in the regular .NET framework were asynchronous only. And this is still true in Windows Phone programming, well, it's still true in Silverlight, if anyone's still doing it. And in phone programming, and now in what do you call it today? Windows Store programming, Windows RT, Windows Modern programming, it's the same thing. Microsoft is saying to developers, your UI needs to be fast and responsive. Therefore, when you are going outside the device to get things, you need to do it asynchronously. You don't have an IIS or a hosting server sitting underneath you to make all that happen for you. On the server side, all these thin clients are calling servers, and the servers have more and more work to do all the time because there's more and more clients calling with more and more pesky things they want done. And the servers, to the rescue come all these new CPUs and cores. So there's a lot of processing power on the machine, more and more all the time, and you don't want to waste it. So the ability to force things to run in parallel. Now again, if you're still in a multi-threading hosting environment, that may not be quite as big a priority, but you may not be. So these two forces that are they're not strictly, I mean they're technical in a big sense, in a way the world is going sort of a sense, are trickling down to us programmers, and I think it's more necessary than it's ever been to be up on these techniques, and thus to the rescue come the latest and greatest techniques from Microsoft. Okay, so I'm going to be showing you a lot of code tonight. At least I thought it was a lot. It took me a while to write it. In the past, I used to write all my code up on the podium, and everyone could laugh when it didn't work and tell me all the mistakes I made. Instead, I wrote a whole lot of code home in my office, and you can laugh when it crashes and burns, and when you see me doing really stupid things. And since I'm trying to program in 3 languages, and I really only program seriously in 2 of them, you can guess which one is. You can guess which one I don't. Some of you here are probably going to be able to find mistakes in what I do. So please raise hands, holler, jeer, whatever, every time there's something obviously wrong in any of the code samples you see. Also, again, if you have trouble reading it or if you have trouble following it, there's a lot of code crammed up on here that you're going to be seeing shortly. You know, again, yell out and I'll do something. I'll read it, explain it, or enlarge it, or whatever. Okay? Now, all these examples are going to be in .NET 4.5 using Visual Studio 2012. That's what you need to use all the latest and greatest techniques. Where I can, if I can remember to, I'll make note of the fact that some of these things are available in previous versions, earlier versions of .NET. How many tonight are using Visual Studio 2012? Half, maybe a third of you. How many are at least on Visual Studio on 2010 or higher? 2010 or higher. Okay, that's a good bit. Anybody still on 2008? Anybody still on 2005? Okay. Outliers. Some of this will work in 2005. So these are the versions we're in. Now, on the other hand, I'm not ready to leap all the way into the future yet, so I truly have never had a chance yet to do any programming in Windows RT. As much as I'd love to, my laptop has Windows 7 on it. I haven't had the time or the courage to upgrade to Windows 8, so I don't do WinRT programming at the moment. But most of what I'm going to tell you about will be, particularly about the task parallel library related stuff, my understanding is it applies to WinRT programming and or to Windows Phone programming, which I also haven't done. How many here have done Windows RT already in some fashion? More hands than I thought. Good. How many have done Windows Phone in some version or other? A few. Okay. All right. So that's the requisites for the code. So here are the techniques: threads, thread pools, asynchronous delegates, asynchronous event handlers, asynchronous tasks, that's the task parallel library, and finally F-sharp asynchronous workflows. Okay, and what I'm going to do is put up a quick slide about each one, and then we'll go in and look at code samples. Alright, so back to the very beginning. Threads and thread pools. This has all been in .NET from day one. You can create your own threads. Every time you create a thread, you give it a thread function, and you tell it to start executing. And it does. Simple as can be. This is actually probably the easiest code to understand that we're going to see all night. How many have done this? Almost everyone. Very good. How many of you think it's a great way to go? There's no one. All right, so just to state the obvious, the great thing about it is that you get to have your very own thread. You create it yourself, it's all yours. That's also the terrible thing about it. That's your very own thread. Something goes wrong with it, you're stuck. The other technique that's been around a long time is an enhancement of this is the thread pool. The thread pool is an object that will exist in each app domain that will manage, like it says, a pool of threads. These threads are, when you start up the app pool, the app domain, excuse me. When you start up the app domain, the thread pool manager starts up, spins up some threads. Exactly how many depends on various factors that you can manipulate if you want to go into machine config and fool with it. But there'll be some threads there, and anytime you want to use a thread from the thread pool, it'll give you one sooner or later. And the nice thing about that is that that thread is not your responsibility. When you're done, you give it back to the thread pool manager, and it will take care of it from there. How many have used thread pool threads in your code? Not as many. Interesting. Now, today, I would discourage anybody from using either of these techniques And I think a lot of people don't want to use these techniques, and yet they do, in part because it's so simple. It's easily the most straightforward way to get started. Okay, so let's look at what we have here. This is, I have a sample application, and I'm not even going to count how many, about 5 or 6, about 7 or 8 different functions that I'm going to call one by one in my submain. So this is a Windows console app. No fancy graphics tonight. All steak, no sizzle. We have a Windows console app, and in each of these examples I'm going to be showing you, the object of the example is to allow the main thread of the program to keep functioning without any interruption from a second thread. Okay? So let's look at what the I'll just run it without calling any of these other functions. Okay, so I need to oops, set it as this. It'd be helpful if I set it as the startup project one. Oh, stop. Okay, so here's our status coming from the C# version of this program. And it just says our status is, you can't see it. Oh, that's a terrible thing. Hang on, sorry. Stop slideshow. There we go. Okay, well, you can't even tell that it's doing anything now because it already scrolled off the end, but okay, so our status is we're moving forward at warp speed. This is all inspired by the Star Trek conference that's coming up about, I think it's it's the middle of April. Sometime middle of April.
Star Trek is May 17th.
May 17th. Well, I'm off by a month.
Tickets go on sale on Thursday at 1:59 p.m.
1:59 p.m. And if it's like Code Mash or some of these other things that sell out in 5 minutes, you might want to go online and grab a ticket or two while you can. Okay, so let's close this other code that we're not going to look at yet and look at this one. Okay, so I have, let's go to the top here. So this is a class called Program. It's got a static field in it called work status, which currently is set to forward warp speed. We have a function here that displays it, and a function here that updates it. And you'll notice that in both cases I am protecting my static string class member there with a lock operator. That's the quick, dirty way to make sure that no thread can get at this thing while I'm in this function either reading it or writing it. How many of you use the lock operator in your asynchronous code? So this is sort of a quick, simple, poor man's way to keep the data from getting corrupted. Okay, so I have a function that reads it and a function that writes it. Then I have a function here that will get a new status, and this has been arbitrarily set to sleep for 2,000 milliseconds or 2 seconds, so that it'll slow things down when it's running. And okay, and then we have all these different variations of functions we're going to call to do the updating. So first thing I'm going to do is display it. Then I'm going to invoke one or other of these functions here that are all commented out for the moment. Then I'm going to, while things are undisturbed, I'm going to go into an endless loop that will keep going as long as the work status stays at forward warp speed. And it'll just display it again and then sleep for 500 milliseconds or half a second. So I'm scrolling along every half second. When this loop exits, if it ever does, we'll display it one more time, display the status one more time, and then we'll quit. Okay? So first, I'm going to call a function that will update the status synchronously, and they should be in the file in the same order that I'm calling them down below. So here it is. We're going to call this get new status, which remember is this thing. Takes 2 seconds to return new status. And once we have the new status, we'll feed it to this update status function up here, which will lock the field and then overwrite it. And then we'll have a new status. So we run that, and wow, our status updated pretty fast. Let's try slowing that down a little. Okay. All right, you get the point. Nothing happens while we're waiting for the synchronous function because it's executing on the same thread in the same process as the main one. So the loop that we were going to run never even started. Okay, we got to here, we displayed it once, and we immediately went to the update status sync method, which didn't come back until the status had already been changed. So by the time we got down to our while loop down here, the status was already something else, so we never even entered the loop. If anyone doubts that, I can step through in the debugger, but we probably, I'll ask you to take my word for it. Now let's try another variation where we're going to update the status on a new thread. Okay, now let's see if I can keep these guys collapsed. Good luck with that, say I. Almost there. Come on. Okay, so here's update status new thread. Alright, create a new thread, give it a thread function, start the thread. Okay, does everybody recognize that this is a function? Okay, what do you call this kind of a function? This is a lambda function, or technically a lambda expression. Okay, a lambda function, or in the form of an expression. Is anybody here not used to writing lambdas, or at least reading them? One hand goes up, 2 hands go up. That's good. I'm glad most of you do. Look at this arrow in the middle. That's in C#. The syntax for this is an arrow that's made out of an equal sign followed by